In textile manufacturing, finishing refers to the processes that convert the woven and knitted cloth into a usable material, and more specifically to any process performed after dyeing the yarn or fabric to improve the look, performance, or hand of the finished textile or clothing. The precise meaning depends on context. Some finishing techniques such as bleaching and dyeing are applied to yarn before it is woven, while others are applied to the grey cloth directly after it is woven and knitted. Some finishing techniques, such as fulling, have been in use with hand weaving for centuries. Others, such as mercerisation, are byproducts of the Industrial Revolution. Introduction. In order to impart the required functional properties to the fibre fabric, it is customary to subject the material to different types of physical and chemical treatments. For example, wash and wear finish for a cotton fabric is necessarily to make it crease-free or wrinkle-free. In a similar way, mercerising, singeing, flame-retardant, water-repellent, waterproof, anti-static and peach finishing achieve various fabric properties desired by consumers. The use of 100% synthetic textiles has increased considerably since the development of textured yarns made of filaments, and the growing production of knit goods. The use of open weave has enabled production of lighter, breathable fabrics to ensure better wearing comfort. The properties of petroleum-based synthetic fibers, most important among them being polyamide, polyester and polyacrylonitrile, are essentially different from those of natural cellulosic and protein wool fibers. Hence, the sequence of finishing operations is likely to be different. While cellulosic fabrics require a resin finishing treatment to impart easy care properties, synthetic fibers already exhibit these easy care criteria and require only a heat-setting operation. Finishing processing of cotton, purification and preliminary processes. The grey cloth, woven cotton fabric in its loom state, not only contains impurities, including warp size, but requires further treatment in order to develop its full textile potential. Furthermore, it may receive considerable added value by applying one or more finishing processes. Singeing. Singeing is designed to burn off the surface fibers from the fabric to produce smoothness. The fabric passes over brushes to raise the fibers, then passes over a plate heated by gas flames. Desizing. Depending on the size that has been used, the cloth may be steeped in a dilute acid and then rinsed, or enzymes may be used to break down the size. Scouring. Scouring is a chemical washing process carried out on cotton fabric to remove natural wax and non-fibrous impurities from the fibers and any added soiling or dirt. Scouring is usually carried in iron vessels called kyrs. The fabric is boiled in an alkali, which forms a soap with free fatty acids. A kyr is usually enclosed, so the solution of sodium hydroxide can be boiled under pressure, excluding oxygen which would degrade the cellulose in the fiber. If the appropriate reagents are used, scouring will also remove size from the fabric, although desizing often precedes scouring and is considered to be a separate process known as fabric preparation. Preparation and scouring are prerequisites to most of the other finishing processes. At this stage, even the most naturally white cotton fibers are yellowish, and bleaching, the next process, is required. Bleaching. Bleaching improves whiteness by removing natural coloration and remaining trace impurities from the cotton. The degree of bleaching necessary is determined by the required whiteness and absorbency. Cotton, being a vegetable fiber, will be bleached using an oxidizing agent, such as dilute sodium hypochlorite or dilute hydrogen peroxide. If the fabric is to be dyed a deep shade, then lower levels of bleaching are acceptable. For example, However, for white bed sheetings and medical applications, the highest levels of whiteness and absorbency are essential. Merce Rising. A further possibility is merce rising, during which the fabric is treated with caustic soda solution to cause swelling of the fibers. This results in improved luster, strength and dye affinity. Cotton is mercerized under tension, and all alkali must be washed out before the tension is released. A shrinkage will take place. Mercerizing can take place directly on gray cloth, or after bleaching. Coloration. Color is a sensation caused when white light from a source such as the sun is reflected off a pigment on the surface. The pigment selectively reflects certain wavelengths of light while absorbing others. A dye can be considered as a substance that can be fixed to a material that has these properties. The color it reflects is defined by the structure of the molecule, and particular the parts of the chromogen molecule called the chromophore group. There are two processes used to apply color: dyeing. Finally, cotton is an absorbent fiber which responds readily to coloration processes. Dyeing, for instance, is commonly carried out with an anionic direct dye by completely immersing the fabric in an aqueous dye bath according to a prescribed procedure. For improved fastness to washing, rubbing and light, other dyes such as vats and reactives are commonly used. These require more complex chemistry during processing and thus more expensive to apply. Printing. Printing, on the other hand, is the application of color in the form of a paste or ink to the surface of a fabric, in a predetermined pattern. It may be considered as localized dyeing. Printing designs onto already dyed fabric is also possible. The common processes are block printing, roller printing and screen printing. Finishing. Mechanical finishing. Raising. Another finishing process is raising. During raising, the fabric surface is treated with sharp teeth to lift the surface fibers, thereby imparting hairiness, softness and warmth, as in flannelette. Calendering. Calendering is the third important mechanical process, in which the fabric is passed between heated rollers to generate smooth, polished or embossed effects depending on roller surface properties and relative speeds. Chemical finishing. Many other chemical treatments may be applied to cotton fabrics to produce low flammability, crease resist and other special effects. Shrinking. Mechanical shrinking, whereby the fabric is forced to shrink width and or lengthwise, creates a fabric in which any residual tendency to shrink after subsequent laundering is minimal. Standard finishes. Quality-oriented calendering. Decotizing. Desizing for woven fabrics. Pressing. Scouring with detergents, alkaline solutions, or enzymes removes foreign matter. Shrinking. Sanforization. Shearing or singeing smooths the fabric by removing the fine protruding fibers on the surface of the fabric. Flame sinching is the standard process. The wet fabric is passed through an array of gas burners at a suitable distance to burn the pills off of its surface. Design-oriented bleaching of woven fabrics removes any prior color in order to obtain a uniform color during the dyeing process. Dyeing adds color. Printing adds color and pattern. Watering adds moire patterns. Handle-oriented fulling and walking adds weight and density. Hydrophobic finishing produces a fabric that repels stains of water. Weighting silk with metallic salts. A polymer adds weight and improves handle. Special finishes for natural fibers. Biopolishing removes the protruding fibers of the fabric through the action of an enzyme. Enzymes, such as cellulase for cotton, selectively remove protruding fibers. These enzymes may be deactivated by an increase in temperature. Mercerisation makes woven cotton fabric stronger, more lustrous, to have better dye affinity, and to be less abrasive. Raising lifts the surface fibers to improve the softness and warmth, as in flannelette. Each finish subjects the fabric to emery wheels, making the surface velvet-like. This is a special finish used mostly in garments. Fulling and walking is a method of thickening woolen material to make it more water-resistant. Decotizing to bring dimension stability to woolen fabrics. Calendaring makes one or both surfaces of the fabric smooth and shiny. The fabric is passed through hot, fast-moving stainless steel cylinders. Sandfrizing or pre-shrinking prevents a fabric and the produced garment from shrinking after production. This is also a mechanical finish acquired by feeding the fabric between a roller and rubber blanket. In such a way the rubber blanket compresses the weft threads and imparts compressive shrinkage. Crease-resist finish or wash-and-wear or wrinkle-free finishes are achieved by the addition of a chemical resin finish that makes the fiber take on a quality similar to that of synthetic fibers. Antimicrobial finish causes a fabric to inhibit the growth of microbes. The humid and warm environment found in textile fibers encourages the growth of the microbes. Infestation by microbes can cause cross-infection by pathogens and the development of odor where the fabric is worn next to skin. In addition, stains and loss of fiber quality of textile substrates can also take place, with an aim to protect the skin of the wearer and the textile substrate itself. An antimicrobial finish is applied to textile materials. Special finishes for synthetic fibers. Heat setting of synthetic fabrics eliminates the internal tensions within the fiber generated during manufacturing, and the new state can be fixed by rapid cooling. This heat setting fixes the fabrics in the relaxed state, and thus avoids subsequent shrinkage or creasing of the fabric. Pre-setting of goods makes it possible to use high temperature for setting without considering the sublimation properties of dyes, and also has a favorable effect on dyeing behavior and the running properties of the fabric. On the other hand, post-setting can be combined with some other operations such as thermosol dyeing or optical brightening of polyester. Post-setting as a final finish is useful to achieve high-dimensional stability, along with desired handle. Heat setting is an important part in textile finishing. Stiffening and filling process. A stiffening effect is desirable in certain polyamides and polyester materials, which can be done by reducing the mutual independence of structural elements of fabric by polymer deposition on coating as a fine film. Hydrophilic finishes compensate for lower moisture and water absorption capacity in synthetic fiber materials, which become uncomfortable in contact with skin. Certain products, based on modified polyamides, make the fabric more pleasant by reducing the cohesion of water so that it spreads over a larger area and thus evaporates more readily. Anti-pilling finish alleviates pilling, an unpleasant phenomenon associated with spun yarn fabrics, especially when they contain synthetics. Synthetic fibers are more readily brought to the surface of the fabric due to the smooth surface and circular cross-section, and due to the higher tensile strength and abrasion resistance. With nitpicking also occurs. By abrasion, individual fibers work themselves out of yarn loops onto the surface, and the garment catches on a point at a rough object. Knitting is susceptible to these effects due to the open weave and bulky yarn. Anti-static finish prevents dust from clinging to the fabric. Anti-static effective chemicals are largely chemically inert and require thermosol or heat treatment for fixing on polyester fabrics. Polyether agents have been found to be useful but should not affect the dye equilibrium on fiber, lest they impair the rubbing fastness. In general, thermosol anti-static agents also have a good soil release action, which is as permanent as the anti-static effect. Anti-static finishes may also be of polyamide type, being curable at moderate temperatures. Non-slip finishes give the filaments a rougher surface. Synthetic warp and weft threads in loosely woven fabrics are particularly prone to slip because of the surface smoothness when the structure of fabric is disturbed and appearance is no longer attractive. Silica gel dispersions or silicic acid colloidal solutions are used in combination with latex polymer or acrylates dispersions to get more permanent effect, along with simultaneous improvement in resistance to pilling or snagging. These polymer finishes are also capable of imparting a soft and smooth handle to synthetic fabric without making it water repellent, fire resistant or flame retardant finish to reduce flammability. Antimicrobial finish. With the increasing use of synthetic fibers for carpets and other materials in public places, antimicrobial finishes have gained importance. Products which are commonly applied are brominated phenols, quaternary ammonium compounds, organosilver-anting compounds, which can be applied as solutions or dispersions. They can also be incorporated in a polymeric film deposited on the surface to achieve controlled release. Bibliography. Collier and M. A Handbook of Textiles, Pergamon Press p. 258, ISBN 0080180574, ISBN 0080180566. Kadolf, Sarah J. Textiles. Pearson, Prentice Hall. ISBN 0131187694. Textile Praxis 401. Befugtung oder Dampfen von Wollgarnen. Textilbetrieb 29. Gleichmäßige beim Garndampfen. Dr. H. J. Henning, Driving. CL. Sustmann, Melian Textilberichte und Untersuchungen über das Vakuumdampfen von Wollgarnen 530.